Assalamualaikum everyone, I'm Ashunaza bintu Kalani. So today I will be presenting about my individual project for electrical power technology subject. Hereby I use my matrix number which I need to use it as my project value. But first I would like to say sorry because of this video. You might not clearly heard me because of I had some trouble with my mic and the video quality is not that good, but still I need to submit it sooner or later. So I will just continue with my presentation. So for the introduction, I would like to introduce a little bit about three-phase system. As you know, three-phase systems are widely used in generation, transmission, and distribution of electric power. Also, this configuration of voltage sources is characterized by a common connection point joining one side of each source. In addition, the three conductors leading away from the voltage sources, which also called as winding toward a load, are typically called lines, while the winding themselves are typically called phases. For a general information, the three-phase power system may become ABC phase sequence, which is positive, and also possible to connect is ACB phase sequence, which is negative. As for the objective, this project aims to analyze the three-phase Y-connected generator. Second is to evaluate the parameters of electrical system. Next is to determine active power in balanced three-phase circuits using 2-watt-meter method. And the last objective is to determine active power using measurement of circuit voltage and current. Moving to methodology of the project, in this project I need to use the software PSIM that I already installed earlier into my PC. PSIM is one of the software that we can simulate the circuit that we draw and put the value that we want. From that, we can get the value and graph clearly as for the data collection for this project. I need to collect the data from my parameters from my matrix number. The resistance and reactance of the loads are given according to my matrix number 1910 91003. Which you can see here, the one that I just bolded with different colors are my values for A, B, C, and D, which I need to use it later for completing this project. From the value given, I just key in the value into the PSIM and the values of my voltage line is 132 kilovolt. Next, I need to change the value according to the value given. After I finish the circuit, I need to run the simulation and get the value for every part, and the simulation will show the graph for the result. Lastly, I need to save the graph and zip the file and simulation. For this, I also prefer the circuit based. For this, I also refer the circuit based on slide that given to us. Here I attached the example of circuit that had given to us, and here is my circuit for the project. For method analysis, I used to analyze the theory calculation. First, I just used the formula for Y to Y connection. So you can see here is the formula I've used on how to calculate phase voltage in phasor. These are all the formula used for calculating the line current, line to line voltage, and voltage load. Here is the formula for voltage and current phase. For transmission and load impedance, here is the calculated value for inductive reactance at transmission, calculated value for reactance at load, and transmission impedance in ohm. This is the total impedance that I got, which 65.9 with 11.43 angle, and my E line that I was given is 132 kilovolt, and it is also in positive sequence. Here is my calculated value of phase voltage for each line and also line currents. There is this one here is load voltage that I got, and also the percentage of my voltage drop for this project. By using 2-watt-meter methods, here is my value for active power at the load, and here it shows how I get my P1, and then this is how I get my P2, and for the total power I just need to add on these two P1 and P2. On this slide, you can see the comparison for my project, which is the calculated and measured value of the project. Moving to the result that I get from the project using PSIM, this one is the result of voltage, VAN, VBN, and VCN. Next, for the result for current A to A, current B to B, and also current C to C. The last one is the result of the power that I get. For the discussion, what we can discuss here is what we know. Three-phase electricity consists of a 3 AC voltage of identical frequency and similar amplitude. Each volt each, each AC voltage phase is separated by 122 degrees from the other. Three-phase connections are suitable for design project because the three vector space voltage can be used to create a rotating field in the motor. In this project, to find the parameter in this electrical system, students are required to use two wattmeter methods, which is conventional method and measuring method by using PSIM software. This electrical system is in positive sequence, which is A, B, C. Given line voltage to me is 132 kilovolt, and it is assuming that EAB is equal to 132 kilovolt. As we know, line voltage leads phase voltage by 30. The frequency is 50 Hz according to the electricity supply application handbook. Normally, generator voltage is equal to the load voltage, but in this case, the generator voltage is not equal to the load voltage. It is because this electrical system has transmission loss. The transmission loss occur at transmission line that can cause voltage drop. Active power is calculated using conventional method. Based on the results shown in table 1, calculated value is approximately the same with the measured value. The voltage probe is placed after the transmission impedance. It is because the line voltage needs to be found after the voltage drop. The voltage of For the conclusion, all the objectives are successfully achieved. An electrical system that consists of a three-phase Y-connected generator, transmission loss, and a load are familiarized after doing this project. Second is the parameters of the electrical system are successfully can be determined in the context of transmission and load impedance, currents, voltage, and acceptable voltage drop. Lastly, the active power absorbed by the loads by using two wattmeter methods and the conventional measuring method is successfully evaluated and analyzed. Thank you very much for watching. That's all from me. Assalamualaikum.